Here is an explanation for the answer to final exam question number 10 in Physics Demystified, 2nd edition. If you have the printed book, you'll find this question on page 514. We're talking here about geomagnetic inclination. Well, first of all, we need to remember what that is. Anywhere that you are on the surface of the Earth, you'll find geomagnetic lines of flux. Those are the flux lines created by the Earth's own magnetic field. Those flux lines will have a certain slant with respect to the surface depending on where you are. If you're near the Earth's magnetic poles, those lines of flux will go just about straight up and down. If you are near the geomagnetic equator, which is the line running around the Earth midway between the geomagnetic poles, these lines will be just about horizontal. Well, inclination, geomagnetic inclination, is this angle right here. We call it theta. This angle. If you have some geomagnetic inclination like this might be what you would find, say, somewhere in Canada. You'd probably find some significant, this looks like about a 40-degree slant. That's pretty significant geomagnetic inclination. If you have a magnetic hiker's compass and you orient it horizontally, you hold it, you know how you hold an old hiker's compass, horizontally, so that the needle can swing around and point towards geomagnetic north. Because of this inclination, that needle is going to dip. It's not only is the magnetic field of the Earth going to pull that needle towards geomagnetic north in a horizontal plane, but the fact that these lines of flux are slanted is going to cause that needle to dip. So what you're going to get is a little bit of an imbalance in that compass. You've probably noticed that kind of thing. Well, we look through our choice of answers, our selection of answers here in this question, and we will find that choice C tells us this. One end of a magnetic compass needle will tend to dip slightly when we have significant geomagnetic inclination.